Hello everybody, my name is John Sefton and I am going to do a series of short videos where I'll be explaining my hypothesis that galaxies and atoms are exactly the same thing. So that's the hypothesis. And so I'm going to be using that hypothesis to explain a number of things that they're having trouble explaining. And tonight I'm going to explain, I haven't even decided yet. Let's explain dark matter. Okay, so in the mid-1970s, they were able to measure how fast stars are going around galaxies, and they're measuring how fast these stars were going. And they found that the outer stars are going like way faster than they thought they should. According to our gravity, the outer stars should go a lot more slowly. So everybody was freaking out, like how could the outer stars, like it was called a flat galactic rotation curve, and they measure the speeds of the stars from the center all the way out to the edge, how fast they're all going, and they graph it. And they thought the curve would tail off, but the curve remained flat. And that's a problem for our gravity, because our gravity doesn't say that it's going to stay flat. So Vera Rubin came up with dark matter, which had been suggested by a fellow named Fritz Zwicky back in the 20s or 30s, or maybe later than that even. And he had noticed that galactic clusters were going faster than they should, and so he had suggested maybe there's some kind of dark matter that was affecting that, some kind of matter we couldn't see, whatever. So ever since then, they've been searching for this dark matter. But galaxies and atoms are the same thing. Right down to the atoms are made out of the same thing as galaxies are made out of, which is smaller atoms. So that means that space is full of smaller atoms. And those atoms would be proportionately smaller than our atoms. If our atom is a galaxy, those atoms are going to be proportionately smaller. So the Milky Way is 10 to the 21 meters. A carbon atom is 10 to the minus 10 meters, so the difference is minus 31. So those space atoms will be minus 41. They'll be 10 to the minus 41. So that's way smaller than the Planck limit. Now in quantum mechanics, they have something, or science, they have something called the Planck limit, where they say that nothing can exist smaller than that limit, which is 10 to the minus 35, because the photons couldn't even react with it. It's so small. But with this galaxies or atoms theory, where you just go down to a lower size, and the atoms are made from smaller atoms, you're already down at 10 to the minus 41. That's 10 million times smaller than the Planck limit. So space is full. It's full of these smaller atoms, and they're just so small that we can't see them. Our photons are waves in them. Our atoms are waves in them. We can't see them because we are what they are made from. So space is full. It's not empty at all. It's totally full. So there is some resistance to things changing direction in space, like when the stars turning around circles around the galaxy. There's some resistance to that because space is not nothing. There is something there. So what happens with disk galaxies is that they are symmetrical, and they are able to use their circular symmetry, and they both rotate and revolve, and they revolve twice as fast as they rotate, so that they'll do a 360 spiral to the bottom and then another 360 spiral to the top. And what happens with this movement is that the disk, all of the opposite sides of the disk will exactly mirror each other, like the one that started at the top and the one that started at the bottom. As the top one goes 360 to the bottom one goes 360 to the top. And then when the reverse happens, the reverse happens, eh? And so there's always the mirror on the other side following each other with this rotation. It's called a one half rows, 1 to 2 rows movement. And it's the only geometric movement where opposites follow, where you can have a sphere created by rotation and revolution, and the two opposites will follow. Whatever's opposite will follow in the same path. So now what you've got going on here is with disk galaxies, they're rotating and revolving in such a way that they draft themselves. And it's like when geese are flying in a V, they fly in a V because they're flying through the air, because it's easier. Because the way the air flows, the geese go with it, eh? And the same thing with a mother duck with her ducklings. The little ducklings get right in behind her, and she probably paddles differently, and she sets up a little draft in her wake, and all the ducklings get pulled along with it, right? And so that's the same thing with disk galaxies. What they're doing is they're rotating once every time they revolve twice, which allows symmetrical formations to draft themselves. And it sets up a really tight standing wave that's pretty much unbreakable. I mean, once something's doing that, it's at a lower energy level than anything around, so it's locked in. And that's dark matter. Disk galaxies have dark matter. Irregular galaxies don't have dark matter. And that's why. And that's how the galaxy model for the atom explains dark matter. So next time, I don't know what I'll explain next time. Next time I'll explain asymmetrical galactic rotation curves. Sounds good to me. Have a good night.